In this section, we are going to study integers as exponents. Integers include positive integers like 1, 2, 3, 4, and so on, 0, and negative integers like -1, -2, -3, and so on. So the first case, the exponent is positive. For example, we have, say, a squared, and notice this is what we call exponent or power. So the exponent here is 2, which is positive. And a, we call it base. And we learned this before. We know a squared means 2 copies of a multiplied. So we multiply a and a. Similarly, if we have x to the third, again, the exponent is 3, which is positive. That means multiply 3 copies of x. So for the first case, when the exponent is positive, the exponent means the number of copies. If it's 2, it means 2 copies, multiply 2 copies of the base. If it's 3, it multiplies 3 copies of the base. 2 copies of a here and 3 copies of x here. Now we're gonna look at the second case. What if the exponent is 0? Say when we raise a to the 0 power. And usually when the exponent is 0, we want to make sure the base is not 0. And that's a special case. And if for any non-zero number, if we raise it to 0, we always get 1. And next we're going to look at when the exponent is negative. This is a to the 0 power is equal to 1, which has been explained previously. If you forgot, a quick explanation is, for example, if we divide a to the second by the a to the second, when we use the formula, we subtract exponents 2 minus 2, which gives us a to 0. But we also know a squared divided by a squared, they can be canceled because the same number divided by the same number, we should always get 1. So that's how we prove, or a to the 0 power has to be equal to 1, because when we solve the problem by 2 different ways. One is by using the formula, subtracting the exponent. The other is by canceling the common factors. We should get the same answer. So that means a to the 0 has to be equal to 1. And this process also explains why the base a cannot be equal to 0. Because if the base a is equal to 0, we're going to have a 0 divided by 0, and which is undefined. So that's why the base a cannot be equal to 0. And the simple way to memorize this is 0 copies of a, and that means we don't have a, and so we actually get 1 because we're doing division. Anything divided by itself, we're going to get 1. So that's something we learned before. Just try to refresh your memory, and that's something we also need to memorize. Raise any non-zero number to 0, we always get 1. Now we can look at the third case, when the exponent is negative. A to the negative power. For example, a to negative 1. What does it mean? It means 1 over a. So one thing we need to be careful is some students got confused by a raised to negative 1 and a times negative 1. They are completely different. So if we don't raise the negative 1, we just do a times negative 1, we're going to get negative a, which is called the opposite of a. Negative sign in front of a called opposite, of a. But 1 over a, it's called reciprocal. The reciprocal of a means we flip a. So when we do a raised, if a is raised to -1, what we do is we can treat a as a over 1 raised to -1. When we flip, so we flip the base, which is a or a over 1. When we flip a over 1, we got 1 over a. So remember that a raised to -1 doesn't mean it is negative. So we can look at an example. 2 to, let's say if we do 2 raised to -1. By the definition, this -1, so this is the definition we have to memorize. What does the negative exponent mean? The negative exponent means the reciprocal. The negative, if it's -1, it means reciprocal. So this negative sign right here tells us to flip. So we're going to get 1 over 2. When we flip 2, we get 1 over 2 because 2 is the same as 2 over 1. So if we flip 2 and 1, we're going to get 1 over 2. So similarly, if I have 2 over 3, 2 raised to -1, it means the answer is 3 over 2. Again, it's not -2. 2 raised to -1 is not -2. Because we're raising that -1. We're not doing 2 times -1. So that's something we have to remember. And these two are very, very different. Okay, so now we're going to look at some more examples. The first example, 1/2 raised to the negative first power minus 2/3 raised to negative first power. And following the order of operations, please excuse my dear Aunt Sally. We have to do parentheses first, but notice these parentheses are just trying to indicate that we raise the entire fraction to negative first power. They're inside the parentheses. There's no operation we have to do. I mean, we can write 1/2 divide 1 by 2 to get 0.5, but it's not going to make the problem any easier because we know that -1 means reciprocal. We have to flip it. If we change it to decimal 0.5, we cannot flip it anymore. So we would like to keep it as the fraction 1 over 2. So now we go by the definition. 1 over 2 raised to -1 means flip 1 over 2. We get 2 over 1. And so we're working on the exponent right now because there's nothing to do inside the parentheses. Similarly, 2 over 3, we don't want to divide them, so we're going to do the exponent. 2 over 3 because negative exponent again means the reciprocal. So let me emphasize this. Means reciprocal of the base. We're going to get 3 over 2. And now we're going to subtract 3 over 2 from 2 over 1. And we have to do this, we have to equal the denominators, multiply first one by both top and bottom by 2. So we get the same denominator 2. 4 over 2 minus 3 over 2. We keep the denominator 2 and subtract numerators. 4 minus 3, we get 1. So the answer is 1/2. Now let's look at another example. Before we look at the second example, we want to go back to the definition of a negative exponent. So we talked about the negative exponent. If the exponent is -1, what it means. For example, a to -1, it means 1/2, which means the reciprocal. But what if we have a that is raised to -2? So a raised to -2, what does it mean? Now again, this negative in the exponent means reciprocal. So what this means is, it means the reciprocal of a squared. So we kind of so when we raise a to a negative second power, it's like doing the reciprocal of a to the second. And we know a to the second, a squared, which is a squared over 1. When we flip top and bottom, we're going to get 1 over a squared. So that's the definition, the second definition. In general, we can do a to the negative third power, which is 1 over a to the third. In general, if we do a to the negative nth, any integer, it could be negative 2, negative 3, negative 4, negative 5, negative 100, it just means 1 over a to the n. So this is the formal definition that we have to memorize for this section. So here, of course, a is positive. Well, a actually could also be negative. So we have here, it's when we memorize it, as long as you remember the negative in the exponent means reciprocal. So it's sort of like doing 2 steps. So when you have negative 2, I would temporarily forget about the negative sign in exponent, which gives us a squared. If we don't look at this negative sign right here, and we get a to the second, a squared. And then because there is a negative in the exponent, that means reciprocal. So we flip a squared to get 1 over a squared. Okay, so now we're ready to look at the second example. If we're going to do 5 raised to negative 2 plus 2 raised to the negative 4th power and then raised to the negatives first. So we're going to follow the order of operations. Parentheses first. So we're going to work out what's inside of parentheses. But inside parentheses, there are exponents. So we have to do the exponents first. 5 raised to negative 2, again, by the definition, it means 1 over 5 squared. Again, ignore the negative sign first. Temporarily ignore it. We have 5 squared. But because it does have a negative in front of 2, we have to flip what we have. So flip a 5 squared, we get 1 over 5 squared. So similarly, so we temporarily forget about the negative sign in front of 4. We get 2 to the 4th. But the negative sign tells us to flip it. So we got 1 over 2 to the 4th. And then to raise to the negative first power. Now we're going to work this out. 5 squared, we know it's 25 on the bottom. 2 to the 4th, it's 2 times 2 times 2 times 2. Multiply 4 copies of 2. That equals 16. And then raise to the negative first. And next, we're going to have to add these 2 fractions by equal the denominator. And notice that at least the common denominator here is going to be 25 times 16 equals 400. So we're going to multiply the first one, both on top and the bottom, by 16 times by 16 times by 16. The second one, top and bottom, we multiply by 25. So we're going to end up with 400 on the bottom, common denominator, and 16 plus 25, that is 41, and then raise to negative 1. Now we're going to use the definition of negative exponent. It means reciprocal. And so pretty much it's like doing 1 copy of 41 over 400 and then flip. Again, negative means reciprocal. So we end up with 400 over 41. That's the answer. To summarize it, this section, the definition is important. So we need to memorize the definition. A to negative 1 means 1 over, right here, 1 over a to the nth. So temporarily forget there's a minus sign, we get a 1. We got a to the n, but that negative sign right here tells us to flip whatever we got. So when we flip a to the n over 1, we can get 1 over to a to the n.